Hey ZooCon, it's Meg Schwamb from Planet 4 and Planet Hunters. I'm here by the virtue of technology. I'm sorry I couldn't virtually be there to give this talk live, but I wanted to thank Grant and Chris for letting me give an update on Planet 4, even though I couldn't make it. So I wanted to just give a brief update, so I'll go straight into my slides. But it's great to be able to talk to all of you who are hopefully listening. Okay, so hopefully that means my slides are showing. I wanted to give sort of an update of what we've been doing with Planet 4 for the past year. Now that the project is about 1.8 months old, we're getting there, getting close to 2 years. So just in case you're not as familiar with Planet 4, I want to give a little bit of the science background. So Planet 4 deals with Mars, and the idea is that at the south pole of Mars, there's a seasonal carbon dioxide ice cap, and it's directly exposed to the atmosphere. And so it thaws in the spring and summer. And unlike on Earth, which has water ice caps, carbon dioxide can sublimate. So it goes straight from solid to gas. And Mars's atmosphere is much thinner and mainly carbon dioxide, and so it's interesting to study the processes and how this ice cap thaws and interacts with the atmosphere from season to season, and help us understand Mars better. And so the interesting thing that's been seen, from orbit as Mars Reconnaissance Orbiter and Mars Global Surveyor before it, and other sort of orbiters, that have gone to the red planet, have seen these dark fans and blotches appear on the south pole on this carbon dioxide cap in the spring and early summer. So this is just one image of that seen from one of the orbiters. And Mars Reconnaissance Orbiter has been orbiting Mars now for nearly 10 years. So it's been doing it for now going on its fifth Martian springtime on the South Pole, at least, and has been imaging with the highest resolution camera, I believe, sent to any planet, but definitely the highest resolution camera ever sent to Mars. And so it can see a basically down to the size of a coffee table or a card table on the surface of Mars. It's that detailed. And the HiRISE team, including Deputy PI, Candy Hansen, has been leading this sort of monitoring campaign to target the South Pole and try to study these seasonal features, these fans and dark features, and how do they evolve over time, and how this carbon dioxide ice cap thaws. And so, on the right is a picture of HiRISE, and on the left is those cyan dots are actually the points on the South Pole that have been targeted repeatedly to sort of try to understand these seasonal processes of seasonal thawing. And again, just to sort of show these beautiful fans and dendritic channels that seem to be produced, you see things like this. You also see blotches and features like that with more isolated sort of channels coming out. And the question is, what do we think is going on? Well, the thought is that because you have that carbon dioxide ice sheet, which forms because the atmosphere basically just freezes out. About 30% of Mars's atmosphere basically freezes out during this sort of winter exchange. And so on the ice, you have a semi-translucent ice sheet because it's the carbon dioxide freezes out, and some of the Martian dust in the atmosphere goes with it. And so you have this semi-translucent ice sheet, carbon dioxide ice sheet, sitting on top of the regolith and the South Pole. And so when the sun hits it, some of the sun goes through, heats the base of the ice sheet, and that the carbon dioxide ice in contact with the surface regolith sublimates, and now you have a gas trapped underneath this ice sheet. And so the thought is that this gas has to go somewhere, and it tries to equilibrate with the atmosphere and comes out as these geysers, these jets breaking through to the surface of the ice sheet. And with it, the thought is that it takes up this rushing carbon dioxide gas, takes with it some of the dirt and dust that's sitting on the surface, trapped below this ice sheet, and brings it up to the top of the ice sheet, where local winds can blow the material into these fans and blotches we see. So this is sort of an artist rendition of what's happening. I definitely wouldn't want to be sitting or standing on the South Pole when this is happening. I can just imagine sort of the noise and cracking as these carbon dioxide jets or geysers break through the ice. And then, we think is that, they're maybe not more than a few meters tall, based on imaging that has allowed sort of 3D modeling that of the surface hasn't been able to actually catch these plumes. So they're only maybe a few meters in height. But then you can, the thought is that the local wind is blowing these, and so when you see in these images on Planet 4 or from HiRISE, which we use on the site, there's these sort of more oval elliptical sort of blotches, and the thought is that maybe that's just a geyser sort of breaking through and just dumping material sort of around it, because there's not enough wind to really blow the dust and dirt particles. And then if there's wind, you sort of get these beautiful fans, and if the wind changes direction, you'd get these multi-directional fans. And I should note, why, you might ask, is why are these things dark if they're actually just the surface? And the reason we think they're the surface is that, by the time that the summer comes along, we don't see any of these features anymore. They're completely gone. And so that makes us think that it's the actual surface material, that dirt and dust from the regolith being brought up by these geysers, because when the summer's over and there's no ice anymore, there isn't really a huge signature of these fans left. So one thing I sort of briefly touched on with these channels, and I just want to highlight them. We're not focusing them on Planet 4 yet. I think it's something that eventually the science team wants to do, is that, as this carbon dioxide gas is rushing through the trapped underneath the ice sheet, it's thought that it's carving these channels maybe over hundreds of years. And they've been dubbed spiders because many of them, if you might have noticed, look like they've got a divot, and then have these radial channels coming off of it. And others look more like maybe it's been dubbed lace terrain. They officially have an arenaeform terrain. I can never say that word right. Arenaeform terrain. Again, just spider is the spider terrain is sort of the nickname. Is these channels being formed by the carbon dioxide gas, year after year, sort of carving into the surface, dirt and dust as it picks up sort of material and brings it out in these jets. So as I said, just to sort of show you the full picture. You get the spring, at the beginning of the spring, the sun comes up on the South Pole after it's been, darkness for a very long time, and, has been forming that ice cap. The sun heats up the bottom of the ice sheet. You get carbon dioxide gas trapped in between the ice sheet and the surface layer. It carves these spider-like channels, and also, the gas breaks through to the top of the ice sheet, bringing dust and dirt that we then think gets blown by the local prevailing winds into fans or blushes. Maybe the wind's not so strong, and then by the end of the summer, you're left with no ice and just these spider channels that still exist. And so then the winter comes again. The cycle continues, and it continues on and on. So, we want to understand how these seasonal blotches and fans evolve over time and how they change from different regions on the South Pole. And so this is just one screenshot. I believe this is a region dubbed Giza. And so you can see in sort of this animation. Let's see if I can do it again. You can see sort of how you get these dark fans. It looks like there also might be some carbon dioxide frost. That's a bright material with the dark fans. And then by the time you get to the end of the summer, the sort of last image, everything's gone. And so that's why we think it's like dirt and dust coming back up, because it, blends basically back into the surface. And so why do we want to do this project? Why do we want to look at this from year to year? Well, it's because we want to understand Mars's climate and how, different things impact it. So one example is Mars, very much unlike Earth. And I should mention that this whole geysers and spiders and seasonal fans is a very alien process. It's not happening on the Earth because, we don't have carbon dioxide ice caps exposed to the surface. So this is very a Martian sort of process. And so if we really want to study it, we have to study Mars to understand it. And Mars also has global dust storms. So if the atmosphere has a lot more dust in it, that means there's a lot more dust in that that ice sheet. So maybe less sunlight will penetrate. Well, what does that do to the number of fans? Well, we can look at that because between season 1 of the High Rising campaign and season 2 of its monitoring campaign, there's a dust storm, global dust storm, and so we should be able, you'd be able to see it by the number of fans, how much carbon dioxide was released. Might tell you something about these processes and how they impact sort of the global weather on Mars. And so, this is due high-rise images just shown here left and right, but the idea is if we can actually mark these individual fans and count them up and get their sizes, we can learn a lot of information about these, a local wind direction, how much carbon dioxide is going, as I said before, and all these kinds of things. And so, there are global climate models. So this is by Toigo et al. 2012. This is a global climate model. It's basically a computer program of every physics and everything we know about Mars to try to replicate its weather and its climate. So, topography, albedo, how much the surface absorbs in different wavelengths, how much it reflects, the emissivity, all these things, craters, terrain, all these things are the thermal inertia are all in this model, and then as far as we can tell, and all the physics it can try to approximate to come up with global patterns, wind patterns, temperature, pressure. So this is showing the wind direction and the near surface wind stress. And so the idea is that with Planet 4, if we could get those individual wind measurements over a function of time, from the monitoring campaign images, we can compare that to models like this from Toigo and see, on the surface, are we actually seeing that the local wind direction matches? And if not, that would be kind of interesting because maybe the model's wrong, because we're going to have this sort of global, this largest wind map at the South Pole from Planet 4 by marking these images. So, I kind of alluded to why we have people do this, but I liked this plot, this figure. I took it sort of taking a whole random subset of the snapshots, the cutouts we show on Planet 4 from the high-rise images. And so you can just see how diverse sort of the South Pole is in colors. It is really kind of beautiful. And this has made it difficult to automate this and have machines identify where these fans are and where these blotches are in their shape. And so the idea is that the human brain is really easy at spotting these. And so that's the goal behind Planet 4, is that, for the first time, we have a way, thanks to your help, of actually trying to get this information by counting the number of fans in each of these regions being monitored from year to year, from throughout a season, and look for these changes and try to understand Mars's climate better. And so this is the Planet 4 interface if you haven't been there. The idea is you draw fans or you draw blotches if you can't really see prevailing direction. And this has really been difficult to automate, and so this has been, Planet 4 is really right now the only way to do this with citizen science. So let me just highlight the team. So Candy Hansen is the PI. The science team includes Anya Porter Akina, Michael A., and myself, as well as many of the Zooniverse development and team who've put together this website and maintained it. So, so thanks to them as well. I wanted to give you sort of a brief update of where we are. So we're now well beyond a year, and the science team really has been working at trying to take your clicks and make it into science, and take that from those individual markings to combine them to identify where these fans and blotches are, and try to start doing the preliminary analysis of trying to figure out what that means. Where we know there's if we know there's a fan there, what does that tell us about the climate? So I just want to show, we finished season 2 and season 3 of the high-rise monitoring campaign basically within the last year. These were the data put in at launch for the project. And so we're now working on season 1. So I'm just showing the statistics for season 2 and 3. So this is all the fraction of volunteers and non-logged in sessions. So whether you're a registered user and used your Zooniverse account, or if you were not used a non-logged in session. So we've had about 84,000 of these sessions, or non-logged in sessions, or logged in registered users. 9.8 million classifications for season 2 and 3. 3.5 million, let me clarify, million blotches drawn and 2.9 million fans drawn. So this is way more than I think the high-rise team ever thought they would get. So you can just see the sheer amount of data that we get to play with, which is amazing. So again, just to show it slightly differently, we have this plot for the paper, which is just showing it breakdown in between non-logged in sessions. The the fraction of sessions over a number of classifications for each of the 2 categories. So if you were logged in or not logged in, so you can see registered users tend to do a little bit more classifications than non-logged in, but that's not so surprising. But again, we're getting lots of classifications from everybody. So the point is that, again, that the money plot is this one, right? That we're getting all these classifications from you guys. So thank you from me and the rest of the science team for spending your time doing this. So let me get into starting to what we've been trying to do for the last, especially 6 months, is trying to, understand the data set and work on our first papers. We hope to have that submitted by the end of the year. So in this plot, on the right-hand side, I'm showing the cutout, the sub-image from the high-rise full-frame image that we show on Planet 4, and then sort of plotted the fans in blue and the blotches in red. And so you can see that occasionally, somebody marks a spurious mark, but people are really identifying these features. Same thing here. And there's many more blotch, ellipses drawn than fans. In this case, I'd probably call these all blotches. But you can see that, again, fans, these are majority fans, and most people mark them as fans. And, the locations are quite good as well. If somebody wasn't sure, marked as a blotch, we can still use that information because we can use the axis of the ellipse. So, lots of information. And we can show it works, that people are actually identifying these features, which is fantastic. The other thing that we're trying to work on is that this is the first data set of its kind for this for these features. So we don't have a catalog to compare to look at the efficiency of the project. Look at how well Planet 4 does at identifying these seasonal fans and launches. So we're making a gold standard data set, as you can see. The different colors represent the different science team members on the top, and on the bottom are just the plotted the volunteer classifications or markings for this one image. And so Michael A. has been working on the clustering algorithm to sort of combine everyone's classifications, and so he made this plot for me. And so, the idea is that you can see here the things that the science team marked, will be identified when we take the majority classifications into account. So where the majority of those circles are. So we can say this is the data set we're building. The science team every week now gets a set of gold standard data to classify now for the last month or 2, and it'll go on for probably another month to sort of build up a set that we can then compare to the full Planet 4 Season 2 and 3 data sets. So by the time the science team's done, we'll only have looked at about 4%, scratched just barely the surface of the data set. But it should hopefully be enough to show that Planet 4 is a success in really being able to identify these features. So that's really exciting. And here's just another image of gold standards. There's nothing in here, and the science team didn't mark anything, and most of the citizen science team neither. This image as well, you can see I am the magenta, and I'm a little bit more conservative than the other science team members who have looked at Mars much longer than I have, but you can see the citizen scientists. You guys have clearly marked all these features, so we can show it works. I want to just bring up, we have a summer student this year, so Chuang Mei is my summer student as part of the Asia undergraduate summer student program, and she's working hard on map projecting the Planet 4 images. So we use non-map projected color mosaics from the high-res camera in Planet 4, but that means we don't actually have the information of where on the South Pole are your actual the actual features you mark. So Chuang has been coming up with a algorithm using sort of software built for NASA missions to process the images and get that map projection and spacecraft information into it and be able to identify sort of the latitude and longitude in the Planet 4 images of your markings. So that's really important, so that we come up with a catalog. We can be able to locate these features, and especially important when we want to look from year to year and even throughout a season on Mars, because then we can take the individual locations and say, what happened to that fan over time? The other thing Chung is doing is she's looking at these frost features. So if you notice, you might have seen earlier on, there's sort of these bright white or bluish sort of these features in some of the images from high rise. We think that's frost, carbon dioxide frost coming out of the vents. The other thing is it could be actually the particles in the fan sinking back into the ice. The ice then gets heated with the sunlight because the dust particles will be warmer, and that might cause the ice to melt and then recrystallize. So not quite melt, but recrystallize its structure, and that might change how it reflects the sunlight, and so that might make them bluer. But no one's really 100% sure. And one thing is that you guys have been marking frost and blue fans and all these things and talk with hashtags, and so we have a sample because we've had eyeballs looking at these images of where cutouts that are frost in it. So one thing that Chung is doing is looking through about 4,000 images taken from these talk collections and hashtags, identifying images that really do have frost in them, which is the vast majority of those images you guys have marked, and then trying to look at some of the properties that of the atmosphere and the time of year and the location that might tell us something about how these things form. So that's what she's working on sort of for the rest of the summer. So she's on talk. Say hello to her if you see her. Also, I just want to briefly say we have a traditional character Chinese translation. My institute, AJA, has an education public outreach office that has helped translate the cited traditional character, also simplified character with help of other individuals at AJA. We also have a German translation now, a Hungarian translation additionally. I want to mention that the education public outreach office at AJA, my institute, has been really trying to promote these translations, and so there's a teacher workshop at the Taiwan Astronomical Museum, and this was a screenshot that Mayan Chow, who's in the EPO office, sent after doing a teacher she sent after doing a teacher workshop at TAM, and so this is a screenshot from one of the teachers there. So she had introduced Planet 4 and several of the other traditional character translations, and so as you can see, Taipei is lighting up on the world map there, which is really exciting. So I just want to talk a little bit about what we're doing now. As you might have noticed, the science team is working on season 2 and 3 data and trying to get that into our first science publication. But we've also sort of switched gears for season 1 and tried to focus on individual regions of interest. So take those targeted regions that I showed earlier in that plot, the surface of Mars, and just focus on completing one region at a time. So that then we could compare that to season 2 and 3 and potentially season 4, which would be an interesting study. So we've done Manhattan first in January, then we went into Inca City, and now we're in Ithaca, where you might notice there's very large fans because it's very flat. So it's a very interesting region to study because there's no topography that's really impacting sort of this process of the fans being created by local winds. So I just wanted to end on talking about something that was announced should be yesterday. So on August 1st, we announced that we're having a Season 5 early release vote. So Season 5 of the Mars Reconnaissance Orbiter seasonal monitoring campaign for the South Pole begins again, starting its 5th season sometime in August. So because we hit the northern autumnal equinox, so the sun should be hopefully high enough in the sky to start seeing what's going on in the South Pole. And so, in collaboration with the High Rise team, and sort of to celebrate the start of the new season of monitoring, they're going to publicly release the first observation from Inca City, Ithaca, or Manhattan, based on your vote, so your decision. So, you've seen these regions and hopefully have a favorite, and you can go to the vote website, so planet4.org/vote. And vote as often and as frequent as you like throughout the month of August for which region you'd like to see the first image from. And I hear that it's often very striking because the sun angle is very low, and so who knows, sometimes there might even be some activity already. So whether it's the boulders of Inca, the lace terrain of Manhattan, or these large giant fans of Ithaca, go vote for your favorite region. So that's all I had to say. I think it's a really exciting time, I think, right now on Planet 4, and just want to say thank you for everybody who's classified. We still need your clicks for season 1, and you know, we'll keep you posted. So I can't obviously answer questions because this is recorded, but we have set up a talk thread. So on Planet 4 Talk, you'll see it under the chat discussion board. So feel free to post any questions you have from this talk or any other questions about Planet 4, and I'll try to answer them over the next week. Thanks very much.